radicals. So on this one here, what we're going to do, let's think about it this way. If I just had a basic old equation and I wrote 8 equals 2x, what am I going to do to get x by itself? Divide by 2, right? Pretty easy equation. Just a simple one-step equation. And I get x equals 4. Now, it's going to be a little bit more difficult here because we got a radical involved. See, Phoenix. So we're going to do the same idea because this is like saying x times radical 2. So we're going to divide by radical 2 on both sides. Same idea, right? Now, here's going to be the problem. We are not going to write our answer as a decimal. So for most of you, if you just type in 8 divided by radical 2, it's going to give you a decimal in your calculator, and we don't want the decimal answer. We want the exact answer in most of these scenarios. And so if I write this, 8 over radical 2, we have some rules that we kind of have to follow when doing math. It's kind of like PEMDAS, right? Order of operations. We want to follow things in the right order. We also have ways that we want to express our answer. Like, for instance, if I have a fraction, I always want to reduce my fraction. Always simplify it. If I have a decimal, I never want to end up with a decimal on bottom. If I have a radical, I never want to end up with a radical on bottom. If you write your answer like this, it's not considered simplified. So we don't want radicals on the bottom of a fraction. So I got to get rid of it. So to get rid of the radical on the bottom of the fraction, we're going to multiply by that exact same radical. Okay? So on top, it would become 8 radical 2. We cannot multiply these two together because this 2 is under the radical and this one is not. So it's just going to become 8 radical 2. Nothing to do to simplify it. And then we kind of have talked about this, but when I take a radical times itself, what happens to the radical? Disappears, right? And so that just becomes 2. Now, we can simplify this, okay? But this is where you got to be really kind of careful. When I simplify this, I can reduce these numbers because they're outside of the radical. I can't reduce this 2 and this 2 because this 2 is under the radical, okay? It's connected to that radical. So I'm going to reduce the 8 and the 2, and that becomes 4 radical 2. Okay, this one's a little bit harder because we got a fraction, right? And so that kind of makes this even more difficult. The first idea, or the first thought here, is we're going to divide by radical 3 to get x by itself. So I have 9 halves divided by radical 3. And same idea. And this won't happen on every single problem today, but we are going to see it from time to time where we have a radical in the bottom. And I'm going to show you some ways to make this simpler and kind of some patterns that we're going to see. But right now we can't leave our answer like this. We have a fraction and we have a radical, and that is a couple of things we never want to finish up with. So we're going to multiply by radical 3 on top and bottom. So this gives me 9 halves radical 3 over 3. Still not simplified. I don't want to leave this as a fraction. If I divided it, I get a decimal. I don't want 4.5 either, so I can't leave it like this, or 4.5. So what I'm going to have to do is kind of like I did over here. The nice thing over here was that the 8 and 2 divided and simplified, right? 9 halves divided by 3, not so much. So I'm going to kind of come up here. If I take 9 halves and divide it by 3, there's kind of a rule, and you've probably heard this before. When I divide with a fraction in the midst, and 3 is really considered to be 3 over 1. If there's nothing on bottom of the 3, it's assumed to be 1. When I divide by a fraction, there's 3 words that you can kind of remember. Anybody remember what those 3 words are? when we divide by a fraction? Not quite. Cross multiply would be if we had like an equation there. We call it keep, change, flip. Have you guys heard those words before? Yes, no, maybe so, hopefully. Okay, when I take a fraction and divide it by a fraction, we call it keep, change, flip. And here's what happens. We keep the top fraction alone. Doesn't change, 9/2. Okay, change means we're going to change the division sign to a multiplication sign. Flip means we're going to flip the 3 to become 1/3. And when we multiply fractions, we do not need a common denominator. Okay? All we need is to just multiply straight across. Nine times 1 is 9. 2 times 3 is 6. And then reduce the fraction. 3 goes into both and becomes 3/2. Okay, so I'm going to move this down here. And so this whole thing is going to become 3 radical 3/2. The radical 3 is still in my answer. So we simplified, basically I just covered this up for a moment to simplify this. And once I have it simplified, then I got to put the radical 3 back in. So this right here would be our simplified radical. Okay. So there's some kind of tricks and rules that you kind of have to remember in there to simplify these radicals. The reason we talk about that to kind of warm up to what we're going to be doing today is because we're going to be seeing problems and doing some of those skills as we go through this lesson. Okay? We're splitting this up into 2 days. So yesterday we made those 2 triangles. We're only going to use the blue triangle today. Okay? And then tomorrow we'll get into the pink one. So you can go ahead and get the blue one out, and then I'll show you here in a little bit what to write on it and talk about that. But for right now, you can go ahead and get the blue one out. Okay, if I were to give you a right triangle, and we call this a 45, 45, 90 triangle. So it's a special triangle, okay? Because in order for all of this to work, these are the angle measures that I have to have. You got to have a 90-degree angle, which is what we're going to see over and over and over again for the next couple of weeks. But specifically, this one has 2 45-degree angles. So what kind of triangle would we have here? What do we call this triangle? Isosceles, good. Because we have 2 angles that are the same, we know these 2 sides are the same. Okay, so I'm going to show you an example here with numbers to kind of help it make sense. And I'll show you how we would have done this the last couple of days. But then moving forward, we won't have to do this every time we have a problem like this. So let's start with a number like 3. If this side is 3, then this side is 3. The last couple of days, in order to find the hypotenuse, we would have said that this is C. That's my hypotenuse, right? And then these 2 would be my A and my B. So if I want to find that third side, going back to the last 2 days, I would write this like 3 squared plus 3 squared equals C squared. Right? A squared plus B squared equals C squared. Okay, 3 squared is 9. 9 equals C squared. And then we add 9 and 9. And then we take the square root. Okay? Now, what we've talked about the last couple days is we can't leave our answer like this, right? We can't leave it as radical 18. That is not simplified. Good morning. Thank you so much. Okay, so we're going to break this down. Okay? 18, what is something that goes into 18? Anything. Okay, 2 goes in there. So we're going to go 2 times 9. We're going to break down 18. 9 breaks up into 3 and 3. And what we notice here is we have a pair, right? And so if I was going to simplify this, I'm going to bring the pair out, and I'm going to leave the 2 on the inside because it doesn't pair up. So my hypotenuse of this triangle over here is 3 radical 2. Okay, but here's the rule. Here's the trick for today. If these 2 sides are the same, which they will be for today, because we have a 45, 45, 90 triangle, then my hypotenuse is whatever this is times radical 2. So notice over here, I had 3, so this just simply becomes 3 radical 2. I don't have to go through all of this work to get here. It's a shortcut, right? That way we don't have to use the Pythagorean theorem to get there. So that's our rule for today. So as I look down here at these problems, and then we're going to write on our blue triangle and show you how to use the triangle. To start off with, this is 8, right? So what's the other leg going to be? 8, right? This is a 45, 45, 90 triangle. They didn't tell me this is 45, but if this is 90 and this is 45, this is what it's got to be, okay? So that means my other leg is 8, okay? The hypotenuse, I don't have to go through the Pythagorean theorem. You could if you really, really want to, but you don't have to. So we're going to take whatever the leg is times radical 2. How much easier is that, right? If you really want to go through the Pythagorean theorem, you could do it. Anybody want to go through the Pythagorean theorem, or would you rather just write 8 radical 2? I think I'd rather write 8 radical 2, right? It's a shortcut. That's what we're doing today. It's much easier to go through that route and find out what the hypotenuse is, rather than having to go through the Pythagorean theorem. And it works every time, as long as it's a 45, 45, 90 triangle. Okay? This right here is my n radical 2 side. Okay, and I usually label it with an A, just because we used A the last couple of days. So this is my A radical 2 side. So that means and we also know that this is a 45, 45, 90 triangle because these 2 sides are the same. If these 2 sides are the same, these 2 angles are the same. If these 2 angles are the same, these 2 sides are the same. It works either way, right? So what do you think the value of x is going to be here? 5. This is 5. This is 5. That's it. Both of them are the same. And for today, once again, these legs are going to be the same. These 2 are the same. This is 2 radical 2, so what's going to be the value of A or X, whatever you want to call it? 2. X equals 2. All right, so let's get out your blue piece of paper, and then we'll do some more examples, and I'll show you how to use this blue piece of paper, okay? You're going to label this blue piece of paper, and I don't have mine labeled yet, but on both sides, I want you to put a 90-degree angle down here in the corner. You can do this with pen or pencil or however you want to do it. If you have a marker and want to use a marker and do it a little bit more, then you can do that. Okay? We're going to label this as 45. We're going to label this as 45. And then we're going to label this side as A, and A radical 2. And we're going to do it to both sides. So once you got it done on one side, you're going to flip it over and you're going to do it on the back side as well. Label your 3 angles, A, and A radical 2. just make sure you put the a radical 2 and the 2 a's in the right spots. The 2 a's are my legs. They're the two sides that touch the 90. The a radical 2 is your hypotenuse. Okay, so let's go ahead and write on there. If you need help or have a question, let me know. Does everybody have a blue triangle? Was anybody here yesterday?
I don't have one.
Oh, sorry. I won't use this till tomorrow, but I'll leave that to you right now.
Thank you.
So make sure you do it on both sides, and I'll show you why we do it on both sides here in a second. This is really a manipulative to kind of help you guys out. All right, everybody got that? Okay, here's how we're going to use them. We've got a few more examples here, but I want to show you how this is used. Okay, so I'm going to take my triangle, and I know mine's not the same color, but it's the same idea, okay? This is one from past years. So I'm going to put my triangle right on top of this, right? Put the 90 where the 90 is. These are my two sides that are the same. So A, and then this would be my A radical 2 side. So I can turn this, flip it, I can put it in any direction I want to. So we know that A is radical 2, right? Because this side is my A. So to get my Y value here, we're going to take whatever A is times radical 2. Well, A is also radical 2. So to end up getting Y, we're going to take radical 2 times radical 2. What would radical 2 times radical 2 give me?
2.
Just 2. So Y is 2. That's my answer. Okay, over here. We'll lay it up there. They have them labeled as X and Y, but what we know, and this is where this is helpful, we know this is a 45, 45, 90. So as I look at this, even though they have it labeled as X and Y, what we will now know about X and Y in this particular instance is X and Y are actually the same thing because they're both A. The hypotenuse is A radical 2. Right? When I lay this up here, it shows me that the hypotenuse is A radical 2. So I'm going to set A radical 2 equal to 19. 19 is what they give me, and we know that's the same as A radical 2. Okay, everybody with me there? Now, what we're going to do is we're going to solve for A. We're going to try to find out what the value of A is, because both of these are A. And this is what we did at the very beginning of the lesson. We're going to divide by radical 2. We can't leave radical 2 on the bottom. So to get rid of the radical 2 on the bottom, we're going to multiply by radical 2. So this becomes 19 radical 2. This becomes radical 2 times radical 2, which is 2. It's okay to have a number on bottom. It's not okay to have a radical on bottom. That's why we couldn't leave it like this. So this right here is my answer. So what we know is that X and Y are equal to each other, and they both equal 19 radical 2 over 2. because they're the same. Okay, let's do the same thing here. I plop this up here, right? 28 is a radical 2. These two are both a. X and Y are both a. Okay, every single time for today, these two legs will be the same. Every time. Because today, that's the only triangle that we're looking at. All of these triangles today are going to be 45, 45, 90s. Nothing else. Okay? Tomorrow, that'll change. But today, that's why we're trying to just do one at a time here. Once again, I'm going to set a radical 2 equal to 28. How do I get a by itself once I set that equation up? Divide by radical 2. Okay? We're doing a lot of the same things over and over again here. Okay, now what you're going to start to figure out here is that there is a pattern. Okay? When I divide by radical 2, I can't leave it like this, so don't ever write your answer as 28 over radical 2. That is not simplified. We can't have a radical on bottom. So now what we're going to do is we're going to multiply by radical 2 over 2. Which is 28 radical 2 over 2. But I can do one more thing. What else could I do here? Divide by 2. Okay, and I cannot divide these twos, okay, because this 2 is under the radical. It's locked in to the radical. But this 2 was outside the radical. These two can be simplified. We did not simplify 19 over 2 here because it's a decimal. We don't want a decimal answer, okay? Over here, it's not a decimal. So on this one, I would say x and y are equal, and they both equal 14 radical 2. They're both going to be the same thing. Once I find one, I've got them both. Okay, ones like this are ones that you're going to love, right? I throw this up here, okay? Here's my 90. So the first thing you do is you match up the 90. These are where these are awesome, right? That's why we make them. That's why we spend the time to make them, because now I know everything I need to know. What would x be in this case? 4, right? Because what did we say about these two triangles? Or this is the only triangle we're going to see today. These two sides are always going to be the same today, guys. Okay? If this is 4, this guy is 4. Every time. Okay? If I know one leg, I already know the other one. So x is a piece of cake. X is 4. I'm going to label this as a, and a radical 2, right? Because that's what I put on my triangle here. I just said, if a is 4, then x is also 4. So over here, to find out what y is, I'm going to take whatever a is times radical 2. And we just said a is 4. So what do you think y is going to be? 4 radical 2. That's all there is to it. Because I already know what the a value is. So this hypotenuse is 4 radical 2. There is no math involved. It's just a matter of using this to get it there. Okay? The other thing I would say here is we really can't, I mean, we could use the Pythagorean theorem, but we're only given one side in most cases. So on a lot of these, we're going to find the two missing sides. But for today, the two legs will always be the same. Okay? Every time. So if you have one leg is this and another leg and the other leg is something else, then you're wrong. At least for today. Okay, on this one here, think about what we did on this problem up here. Okay? Because this is a, and a radical 2, right? If I set a radical 2 equal to 30, what are we going to do to get a by itself? Set it up there like that. How do I get a? Divide by radical 2. Okay? So when I divide by radical 2, you can show me all the work that's being done here, right? But we're going to divide by radical 2, and then I got to multiply by radical 2. And what's always going to happen is the 30 is going to be cut in half. Can I cut 30 in half? Yeah, it's 15, right? So this would be 15 radical 2. And that is your x and your y. A is the same as x and y in this case, because we label those two the same. Now, do you guys kind of see how I jumped and skipped a step there, rather than going through and dividing by radical 2 and going through all that? Anybody lost from how I did that? Basically, I did the same thing I did here, except I didn't show all the work to get there. Everybody okay with that? Okay, it's a little bit quicker, okay? All right, let's look at this one here. This one is a little bit different. Always take your triangle, throw it up here just like it is, okay? That way we can see what's what here. It's a little bit easier today. This triangle is, you guys might not want to hear this, but this today is going to be a little bit easier than what we're going to do tomorrow, because tomorrow all three sides are going to be different measurements. Today, two of them are the same. So that's what makes this one a little bit easier than what we're going to do tomorrow. Okay, so we're going to say a radical 2 equals radical 10. Radical 10 is my a radical 2 side. All right, everybody with me there? Questions on that? The hypotenuse in this case is a radical. So, to get a by itself, we're going to divide by radical 2. Now, we haven't seen this yet. But if I have a radical on top and a radical on bottom, do you think I can divide those two? What do you guys think? A radical on top and a radical on bottom. Is it okay to divide? Yes, as long as they're both radicals. If this was radical 10 and this was just a 2, can't divide it. But as long as this is a radical and this is a radical, we can divide because they're both under a radical, and this becomes radical 5. Okay, so x and y both equal radical 5. And that's simplified. We could try to break it down at this point, but radical 5 doesn't break down, right? So we just leave it as radical 5. Okay, once again, lay my triangle up here. It looks very similar to the one we just did. This is, and the first thing I always do is I label the three sides. A, and a radical 2. It tells me the two sides that are the same. We know these two are the same. This is the different one, okay? And then I'm just going to set up an equation. I'm going to say a radical 2 equals 10 radical 2. To get a by itself, we're going to divide by radical 2 again. And those radical 2's knock each other out. And so that leaves me a is 10. And if a is 10, that means x and y are both 10. They'll always be the same today. Okay, a couple more. I got radical 10 up here. Once again, I can rotate this, I can flip it, I can make it look just like the one that I have. All of these triangles are going to look a little different, right? They're going to be sitting in a little bit different area. That's where this is going to come in so helpful. So what other piece is the same as radical 10? X or y? We know two of them are going to be the same. Which one is the same as radical 10? X, right? These are my two legs. So this is radical 10, this is radical 10. Because as we just talked about, this is my a and this is my a. Those are my two legs. This is a times radical 2. So that means x is also radical 10. The two legs are the same. Okay? Y is going to be a radical 2. But I know the value of a is radical 10, right? A is radical 10. They're the same thing. So what we're going to do is we're going to take radical 10 times radical 2. Can we multiply those two things together? Yes. As long as they're both radicals, we can multiply them. If this was just 10 and this was just radical 2, then I would just say 10 radical 2. That's all I could do. But as long as they're both radicals, kind of like we did over here. As long as they're both radicals, we can divide them. As long as they're both radicals here, we can multiply them. Okay? So this would make this radical 20. Am I done? What do you guys think? Can we leave an answer as radical 20? Can we simplify it? That's what we got to ask. Okay, that's a good question. Okay, we got to see if we can simplify it. So we got to try to break this down. Sometimes we can, sometimes we can't. I got to see if we can break it down. What's something that goes into 20? 2 and 10. Okay, you could do 2 and 10. You could do 4 and 5. You can do anything that goes into 20. Anything you want. Okay, 10 breaks up into 2 and 5. So we got a pair of 2's, and we got an extra 5. And so then that tells me that y is 2 radical 5. Whatever I have pairs of is going to come out. Whatever is not paired up is going to stay in. Okay? So always make sure you simplify it, if you can. Sometimes we can, sometimes we can't. If it was radical 13, we can't simplify it, right? Only thing that goes into 13 is 1 and 13. So that does not simplify. Some numbers will simplify, some numbers won't. Okay, almost there. Always take this triangle, lay it up here, and label the triangle. You got 3 sides. These 2 sides, and as you guys become better and better at this, you probably can do it without the triangle, but until we get really, really good at it, take the time to do it. Okay, that's what they're there for. That's why we're letting you use these. We'll let you use these on your quiz and your test, okay? Take advantage, know how to use it. That's a really big deal. So a radical 2 equals 2 radical 14. This is my a radical 2 side, and it's equal to 2 radical 14. I want to get a by itself. So to get a by itself, we're going to divide by radical 2. Can I divide this 2 and this 2? No. This one is not under the radical. This one is. Can I divide 14 and 2? Because they're both under the radical, right? So I can divide those if they're dividable, okay, which they are. And that would be my answer. So that means x and y are both the same, which is 2 radical 7. Okay, it's just a matter of kind of knowing the patterns more than anything else. There is no big idea today.